In this problem, we are to simplify and write the trigonometric expression. That's this guy. It's an expression, and it has trig functions in it. The trigonometric expression in terms of sine and cosine. So I'm going to write that down. And then part of the problem some of my students are having is they just don't understand what this guy is right here. So what that is we have to tell students when to stop working on the problem. And we didn't want to give you the answer to the problem ahead of time, otherwise you could just type it and get it right. So the idea is we want you to work on the problem until you get an answer that looks like some equation squared. And if you're not used to function notation, that's exactly what this says right here, that you're going to get some function, some equation. Its input's going to be t, of course, so f of t. And it just turns out it'll come out where you have that equation being squared. So don't stop working on the problem until you get a single trig function squared. So I noticed that I have a secant in the numerator and the secant in the denominator, and I'm tempted to cancel that if I was a beginning student. Let me show you why that does not work. However, I am going to take advantage of the fact that I have it on top and bottom, and this is just one way to do the identity, but not, there's other ways of doing it. So usually I say turn everything into sines and cosines, and that, maybe I'll make a second video to show you how to do it that way. But I'm going to take advantage of this. But first of all, let me show you that you cannot cancel terms. Anything separated from addition or subtraction symbol like this is a term. So this is one term, this is the second term. These do not cancel. If you do that, you're going to get it wrong. It would be like saying 12 minus 6 over 6 or something, and you want to cancel the 6's and say the answer is 12, whereas it's most obvious that 12 minus 6 is 6. And 6 divided by 6 is 1. So the right answer is 1. And if you go canceling these 6's, you're going to say the answer is 12, which is obviously wrong. That does work, by the way, if it's being multiplied. But if it's being multiplied, we call those things factors. So a good rule to remember is that you can cancel factors, but you cannot cancel terms. That, of course, necessitates that you know the difference between a term and a factor. Anyway, what you can do, though, is you can break the fractions apart. So with my 12 minus 6 over 6 example, you could write that as 12 over 6 minus 6 over 6. It's the opposite of subtracting fractions, right? With subtracting fractions, if you have a common denominator, you could subtract the numerators, copy the denominator. Gosh, I don't know why I always use 6's in these denominators in these videos. I'm not sure. But anyway, to show you that it works, 12 divided by 6 is 2. 6 divided by 6 is 1. And if you finish the problem, 2 minus 1 is 1. And that is the answer, the correct answer to the problem. So I'm going to do that here, except without it being numbers. They're trig functions, but same rules apply. These trig functions, after all, for a given t value, represent numbers, right? You give me a t value, I'm going to take the secant of t, and it's going to become a number. So in the end, this is these are numbers. They're just an abstract form of numbers. So I have secant that be over secant minus cosine over secant. I'm not sure that this is the easier way to do the identity, but this is a way, right? Just manipulate using rules of arithmetic, but impose those rules on trig functions. So at any rate, the whole goal here was to write that as 1. Secant t over secant t is 1. And then cosine t over secant t can be written as follows. You have cosine t, and then secant t, if you remember the definition of that, is 1 over cosine. And then if you remember right, let me write it this way. Sometimes it's easier to explain if I write it this way. Instead of writing this as a division bar here, I'm going to write it horizontally with division. And remind you that whenever you divide a fraction in math, then the rule is, and it works with numbers but also works with trig functions, that you can change the division to multiplication and then reciprocate this. So if I reciprocate this, it would be, this is multiplication, reciprocating this gives me cosine, and then I have this, which I can write as 1 minus, now cosine t times cosine t, of course, is cosine t squared. We just tend not to write it that way. We tend to write the 2 here instead, but it means the same thing. Now, this, again, I said there's an identity that should make you salivate like Pavlov's dog, and it's sine squared plus cosine squared. I'm using the variable t here just because that's the variable in this problem, but put any dummy variable that you want. So this wouldn't make you salivate perhaps unless you do a lot of problems. You realize this is just a rewrite of that if you know sine squared plus cosine squared is 1, then if you just imagine subtracting the cosine squared over to the other side, you probably can do that in your head, but I will I don't think I have enough room to write it. So the idea is if you subtract that over, what are you going to get? You're going to get sine squared on the left-hand side. If I subtract that cosine squared over, you're going to have 1 minus cosine squared, and I haven't given myself enough room to write that. But at any rate, the idea is then when you see 1 minus cosine squared, then of course you could replace it with sine squared t. So this is a rewrite of the Pythagorean identity, right? And then you can just substitute it as sine squared t. So now this starts to make sense that my answer can be thought of as a trig equation, which is sine t. It just turns out that it's being squared. So this over here just says, you can stop working on the problem when you get to a single function. It's just it works out that it's being squared, so we had to write that. So what is the equation that's being squared? And that's this guy right here. My f of t, all right, the thing that's being squared would be the sine. So we wanted to give this inside function here. What is the function being squared? And it's right there, sine t. So that's what they want you to write in the answer box. Again, I ought to go to try this, but I think if you just write sine t, Math.AS does not like that. It marks the answer wrong. I think it wants you to put parentheses around the t. So this is just one way to do the video. I'm thinking I might do another, but I'm running out of time on this video. It's getting kind of long. I might make a second video where I don't break the fractions apart and just change everything to sines and cosines. That works as well. Probably involves finding a common denominator of some fractions. It looks different, but in the end, you'll get you to the same result.